Good morning. So we are starting today a new unit, which is the quadratic unit, and then we're going to learn how to graph quadratics. So something that you probably want to do first before you start this unit, if you don't know what the word quadratics mean, you probably want to look that up. And then this is something that we cover in grade 10 applied. We start with the quadratic. And just as a quick reminder that quadratic, they have a quadratic graph has a U-shaped graph that looks like this, or it could look like this, right? Or if you're just looking at like part of it, it could be looking like this, right? Where we're only looking at one part of the graph. And we call this graph, the quadratic graph, we call it a parabola. All right. So today we are going to start with the graphing quadratics. How can we graph it? How do we know it's quadratic and things like this? So, so after you do the terminology quiz, you can, so you're going to do the terminology quiz here. It's a matching quiz like we've done before. Now we're going to look at the following question. Oil and water do not mix. When oil is dropped into water, it tends to spread over the surface area in a circular pattern. Suppose that oil is laying on the surface of a body of water in a circle with a radius of 1 meter. The oil spreads to extend the radius by 1 meter per hour. So what do we have here? We have the area of the spill over the first 8 hours. Okay, so what's happening is that we're increasing the radius by one by 1 meter every hour. Okay, so you see here that this is the radius, this is radius, and so on and so forth. So radius 1, 2, 3, 4, 5, 6, 7, 8. And then we are going to find the area. Remember that the area of a circle is pi times the radius squared to the power of 2. Now, if I want to find the area, what I'm going to do is I'm going to plug in the radius into R and then find what the area is for that radius. So what I have to do is I have to do area equals to pi times 1 squared. Bad math says you have to do the exponent. So you're going to do 1 squared first, which is 1 to the power of 2 is 1, times pi, and that gives you 3.14. For the second one, you're going to do A equals pi times 2 squared. So that's going to be area equals to pi times 2 squared. 2 to the power of 2 is 4. So that's going to be pi times 4, and that's going to be 12.57. As you can see here, the area is rounded to 2 decimal places. And then we're going to go to the third one. We have area equals pi times 3 squared. You're going to do 3 squared first, so that's 9. 9 times pi, and that's going to be 9 pi, or pi times 9, doesn't matter, and that's going to be to 28.27, and so on and so forth. So you're going to continue until you get the first 8 hours. So what we did here, we did find what the area is, and then this is the graph. So as you can see, this graph here, it's going up, right? And it's only half of what I've told you. So remember that a quadratic would have a parabola like this. In this case, we're only dealing with this part because I don't have negative radius, right? So that part technically will look like this, right? But that part is not going, we're not going to do that part because we don't have negative radius. It doesn't make sense that you will have a negative. Now, so what we have seen so far, we've seen an equation, we've seen a graph. Now, how do I know that it is quadratic? From an equation, a quadratic will have a degree 2, okay? So a quadratic equation, how do I know it's quadratic, is when it has a degree 2. From a graph, it's gonna look like a parabola shape. So it's gonna look either up or down, and it could be part of it, not all of it, but that's gonna have that like bell shape. Now, how about from a table of value? So if I have a table of value here, how can I figure out if it's quadratic or not? So to figure out if it's quadratic or not, we have to do what we call the finite difference. And a finite difference is when you're doing your differences. Difference means subtraction, okay? So let's look at this. So I have my y values here, which is the area. So this is my y value. In order for me to find the first difference, so first difference is y2 minus y1, okay? So you're gonna start with the second y value, and then you're gonna subtract the first y value from it. So it's gonna be 12.5, this should read 7, minus 3.14, okay? And then you're gonna take this and subtract this from it. And then you're gonna take this and subtract this from it. So you're gonna keep going. So you take 28.27, subtract 12.57. So the lower y value minus the higher y value. And then you're gonna keep doing that until you finish all the y values. So the last one here, that's going to be 201.06 minus 150. 3.9, okay? So you're gonna keep subtract. As you can see, we left the first one blank because I have nothing on top of the 3.14, so I moved down 1. Now, if I look at the first difference, so if I'm looking at this first difference, I see that it's 9.42, 15.7, 21.99, 28, 34, so on and so forth. So there's no consistency. It's not constant. Since it's not constant, I know that it is not linear, because if it's constant, then you will have that as a linear function. So it's a line. It's a constant line function. Now, if this is not constant, then I have to move to the second difference. To move to the second difference, what you have to do, you have to take the first difference and subtract them from each other. So you're going to start with the bottom and then subtract the top. As we did in the previous, in the y values, we're going to do the same thing with the first difference. So you're going to be 15.7 minus 9.42, 21.99 minus 15.7, and then so on and so forth. So you're going to do the subtraction as you can see here. Now, what you look at right now, so you're looking, we call this a second difference. And then if you're looking at the second difference, it's 6.28, 6.28, 6.29, 6.24, 6.36. They're kind of constant. They're kind of the same. And this is what we're looking for. If the second difference is constant or almost constant, remember that in this case, the reason why they're not constant is because we are rounding, right? Pi is not a number. Pi is at 3.14 and has infinite number of decimals. So I had to, at the end, round. So, and because of the rounding, that's why we see that discrepancy, that little bit of difference here. So that's fine. Now we can still say that these are constant, or they're almost constant. So because they're almost constant, then we can say that it's quadratic. So we've learned 3 things so far. If I'm looking at the equation, the degree has to be a degree 2. So the highest degree is degree 2. If we're looking at the graph, it's gonna have to have a parabola-shaped graph. And if we're looking at a table of value, the second difference has to be constant. So note that, let me just clear this. So we have 3 mathematical models. And the 3 mathematical models are the equation, the graph, and the table of value. So the algebraic model is pi r squared, and it has a degree 2. The graphical model displays a characteristic of a relation of degree 2. Remember, we said it's a parabola shape. And then the table of values has a second difference of approximately equal. Okay, this is what we're looking for. So remember, degree 2, if it is an equation, parabola, and if it's the second difference has to be constant. So the general form for a quadratic equation in standard form is ax squared plus bx plus c equals 0. okay? So, or y equals ax squared plus bx plus c. So an example would be y equals, as long as a cannot equal to 0. So an example would be y equals x squared plus 2x plus 1. Or I can have y equals 4x squared plus 5. Or I could have y equals negative 2x squared. Done, right? So all of these are called quadratic because the highest degree is a degree 2. Now, is this quadratic? No, right? Because this one is linear, because you see here there is no degree and that's a degree 1, so that's linear, okay? So you're always looking at the highest degree and then you're making sure that the highest degree is 2, and if the highest degree is 2, then it's quadratic. All right, so this is what you're going to do. You're going to do differences, and then you're going to make a table of value and graph and find the first difference and determine if it's quadratic or not.